So previously we highlighted that you may be asked to draw the diagram of a drainage basin hydrological cycle, and we say that a systems diagram which shows inputs, stores, flows and outputs is much better than a one that shows the trees, the clouds, the rainfall, the glaciers, rivers, lakes and oceans, for example. So now moving on with that, we have highlighted that the infiltration capacity is the maximum rate at which rain can be absorbed by the soil in a given condition. So now you can be able to understand the influence of ground cover on infiltration rate. So for example, we may have a table, right, that shows ground cover and then infiltration rate millimeters per hour. So on a old permanent pasture, we can have the infiltration rate at 57. On permanent pasture that is moderately grazed, you can have infiltration rate at 90. Permanent pasture that is heavily grazed, you can have infiltration rate at 13 millimeters per hour. Then you have the strip cropped, you can have infiltration of 10 millimeters per hour. Then water, or that is weeds or grain, you can have millimeter rate at 9 millimeters per hour. Then the clean tilled land, you can have 7 millimeters per hour. Then the bare crusted ground, you can have the infiltration rate at 6 millimeters per hour. So you can be asked a question on how to comment on the influence of ground cover on the infiltration rate. So what you'll be doing is you're looking at the infiltration rate that is there. For example, that is 57. Then you look at, is 57 high infiltration rate or low infiltration rate? So what you are then going to comment will be in relation to the rate at which the rain can be absorbed by the soil in a given condition. So the condition that we are given here is old permanent pasture with an infiltration rate of 57 millimeters per hour. So the infiltration capacity there, you are going to relate that to say, so how is it going to affect the infiltration capacity, the rate at which water is going to be absorbed? So now let's move into soil moisture, which we said we are going to be discussing about. So soil moisture refers to the surface water in the soil. Field capacity refers to the amount of water held in the soil after excess water drains away, that is saturation or near saturation. Wilting points refer to the range of moisture content in which permanent wilting point of different plants occurs. They define the approximate limit to plant growth. Through flow refers to water flowing through the soil in natural pipes and percolines, that is, lines of concentrated water flow between soil horizons. Groundwater refers to the subsurface water. Groundwater accounts for 96.5% of all fresh water on the earth. The permanently saturated zone within solid rocks or sediment is known as the phreatic zone. The upper layer of this is known as the water table. Base flow refers to the part of a river's discharge that is provided by groundwater seeping into the bed of the river. It is a relatively constant flow, although it increases slightly following a wet period. Recharge refers to the refilling of water in pores where the water has dried up and or been extracted by human activity. Hence, in some places where recharge is not taking place, groundwater is considered to be a non-renewable resource. So aquifers are rocks that contain significant quantities of water. A spring is a natural flow of water from the Earth's surface. It occurs when the water table, the upper right? Surface of saturation within permeable rocks occurs at the surface. So now, getting to understand these terms will help you in having the knowledge on the drainage basin system. So our next session, or our next topic is on rainfall discharge relationships within the drainage basin. So keep in mind of these key terms: aquifers, spring, recharge, water table, base flow, groundwater, through flow, wilting points, field capacity, soil moisture, runoff, the infiltration capacity, infiltration, evapotranspiration, transpiration, evaporation, potential evapotranspiration, interception loss, through flow, stem flow, precipitation, interception, and the term drainage basin and the hydrological cycle. So all these terms